How to solve an equation that is where lines either cross. This is what we did yesterday. So where they cross, if they're crossing at exactly the same time, or if they're not crossing at all. Okay? Remember, these are no solution. These are one solution, which is a point we're trying to find. And these are always the same solution, or infinitely many, or all reals. Okay? So those are the situations. We did those by graphing, but you can also do them without graphing, where you can just use one equation in place of the other. So let's try one of those. So I'm going to show you what that might look like. Okay. So let's say we have these two equations. Are they both lines?
Yes.
How do you tell they're lines, by the way? How do I know they're in a line and they're not something else? No, there's something about the x. Is this, well, let me show you. So I got a question. Is that a line?
Sure. No.
No. Is this a line?
Oh, no. No.
Yeah.
No.
No, still not a line. Is this a line?
That's not till the second power.
Is that a line?
Yeah. No.
No. None of those are lines. So how are these two lines? How are these lines? Go ahead and write down.
The x power.
Yeah, the x and the y are only to the what power? First power. That's the way you can tell something is linear.
No.
Okay, which means it would graph to be a what?
Line.
A line. Could I graph these?
Yeah.
Yeah. Where would I start the top one? 4 on the what axis? On the y. And I would go up how many? 3 and over 1. Is the second one ready to graph?
Yeah. No.
No. If I solved that for y, would I get some fractions?
Yeah.
Yeah. It's not going to be fun to graph, right? It's not going to come out as perfect points necessarily. And so this is why I'm showing you a different way. Because it's not easy to do. But there's an easier way to do this. Okay? It's called substitution, which is what we're going to be doing today. Now all I need to do is, do I know what y equals in the first equation?
Yeah.
What does y equal in the first equation?
4.
Well, 4 is part of it. What does it equal, Sally? What does y equal in this top equation?
3x plus 4.
3x plus 4. So 4 is part of it, but it's 3x plus 4. The whole thing is equal to y. So all I'm going to do is replace this y with this whole thing. That's called substitution.
Huh.
Now, think about this in a basketball game, or any game, or soccer, whatever. And we've talked about this before when it comes to substitution. So like, let's say Seth was in the game, and then we put, I don't know, Rachel in the game, okay? For Seth, okay? What would Seth have to do?
Go out of the game.
He would have to leave the game, okay? That's important. Somebody has to leave for the other one to go in. Are you with me on that? So this y has to go away, and what am I going to replace it with? 3x plus 4. Now, think about this. How many variables are in this equation?
3. There are 2.
There's 2. There's a what and a what?
An x and a y.
An x and a y. Can I actually get a numeric value for x and y with just one equation and 2 variables?
Yes.
Think about what I'm asking there. Can I get a numeric value, meaning that it's equal to a number, for an x and a y with only one equation and 2 variables? It's impossible. Top equation, notice, I have a variable by itself. I know what it equals. Sally said it equals 3x plus 4, right? But is that a numeric value? No, it's a variable value. It still varies. The only way to solve it is to get one equation with one variable. That's my goal. But right now I have two equations with how many variables in each one? 2. So how do I get it to one equation with one? I replace the variable. I take out Seth, I put in Rachel. So that all of the only things in the game are Rachel's. Okay? There's only going to be X's in this game. The Seths, the Y's, are gone. Are you with me? And that's what we're going to do. We're going to replace them. Okay? So I'm going to put in 2x minus 3, and then how come I started a parenthesis there?
The time.
Not only the times, but it reminds me of what I'm replacing. Okay? So anytime you use substitution, you should put a parenthesis around it, whether there's going to be a times or not. Okay? Even if that was just a plus y, it's a good idea to put parentheses around whatever you're replacing. So what should I write down now, Dakota? -3 what? What should I put there? What am I replacing y with? Huh? 4 is part of it. What am I replacing y with? The whole thing, what? 3x plus 4. Make sure you put the whole thing in. Okay? Y equals the whole thing. That's what Sally said. So if it equals the whole thing, and I'm replacing the y in the second equation, I've got to put the whole equation in. Okay? So that's the key. This is what substitution is. Equals what? -19. That didn't change, right? The only thing that changed is y is no longer y. It's what y equaled, which was 3x plus 4. Now what do? I got to solve it. So that is the tough part. The tough part is actually just a math you already know. What should I do first? Distribute. Who said distribute? Good job, Dakota. What should I distribute? The -3. Yep, I want to distribute this -3 through that parenthesis. What does distribute mean? Times. Okay? So I'm multiplying through the 3. So Tristan, what am I going to get? Multiplying that together.
9.
Positive or negative?
Positive.
A negative times a positive is a negative. 9 what? X. Good job, Tristan.
I'm proud of you, Tristan.
-1. How come it's minus, by the way? Negative times a what? Positive. Okay, so I get minus what? Tristan, what do you get? 3 times 4.
12.
12. Okay. Equals -19. Now, here's where a lot of kids mess up. I see kids do this. Tell me where I made my mistake.
Nope.
How come that's a mistake?
You gotta add them together.
Yeah, they're on the same side. I have just now minus 4x from the left and done nothing to the right. Are you with me on that? Don't make that mistake. I see kids do this sometimes. Bad mistake. Don't do that, okay? These are on the same side of the equal sign. Can you see that? Here's the equal sign. These are on the same side. I just combined them together. I do the addition or subtraction. So, Nick, what will I get when I take 2x minus 9x? What's 2 minus 9?
-7.
-7x. Okay, so that's going to be -7x. Minus 12, that didn't go anywhere, equals -19. Now that you've distributed and combined your like terms, what's the next goal? By the way, those are kind of keys. Distribute, collect like terms. Every time you do this substitution method, you're going to distribute. You might want to write this in your notes. So take out your blue books, or green books, sorry. Take out your green books.
Yeah, reach it. Sorry. Oh, look, mine's not.
And
good.
turn to 5.2.
Smells like a campfire.
And page 129. There's a spot there for, well, wait, I don't want you to put it on that page because that back page is part of the assignment. But let's put it on page 127. Put it on page 127. So turn to page 127 and let's look at the steps here. Okay? So we're going to look at some steps. By the way, I still teach with steps and most math teachers don't. They want you to discover everything. But I actually think it helps a little bit. First of all, what did we notice here? We had a variable by its what? Self. First step. Step one. Get a variable. This is what I want you to write in your notes. By itself in one, not both, but in one equation. That's the first step. Now, a lot of times this step was already done for you. Was it already done for me here?
Yeah.
Yeah, the variable was already by itself. Y was by itself, right? So a lot of times this first step is done. What was the second thing I did? Somebody tell me. What was the second thing I did?
Substitute.
I did. I substituted what?
For y equals
For y, I substituted for y. What did I substitute for y?
3x plus 4.
3x plus 4. See how I replace that? I replace the y. So that's what you want to put. Substitute or replace the solved variable in the other equation. Okay? So notice I have this solved variable, y, equal 3x plus 4. This is the solved variable, this y. I replace it in the other equation, see? You're going to substitute or replace the solved variable in the other equation. Okay, so I replaced it right there. That was my second step. What was the third thing I did? So once I replaced it, what did I do here? It's what Tristan tried to do, only you did it, Seth.
No, I didn't. That was Tristan.
All right. So what did I do with this 3?
I can't remember.
Distribute. So that's the third step. Distribute if necessary. And distribute means multiply, right?
Yeah.
If necessary. Again, if that's just a 1, if this was just a y, right, then that wouldn't really be necessary to distribute. If there was nothing in front of the y. You with me?
Yep.
But if there's something in front of the y, you're going to have to distribute. Then the fourth step, what was it? What did I do right here?
Added.
Yeah, I combined it. I combined what?
9 and 2.
Like
Oh yeah, like term.
terms, which is 9 and 2. I mean, you're right. I combined the like terms.
No.
Then the fifth step is get the variable what?
By itself.
By itself. That's my next step.
Yeah,
Get
I went to bed early.
the other variable, other meaning not the one that we've substituted for, but the other one. Get the other variable by itself. Okay, write these steps down because this is what you're going to do. Okay, now what should I do? Then on this equation. So, Ryder, what should I do on this equation to get the variable by itself? Want to get that x by itself. What am I going to get rid of?
12.
I got to get rid of the -7 and I got to get rid of the -12. Which one do I get rid of first?
12.
Yeah, get rid of what's adding or subtracting. The 7 is multiplying, okay? So get rid of addition and subtraction before you get rid of multiplication.
Oh, yeah.
So I'm going to add 12. -7x equals, what's -19 plus 12?
-7.
-7. What should I divide both sides by, Seth? Seth, what should I divide both sides by?
-7.
Okay, and what will I get?
-1.
Ah, +1. How come?
-10.
Negative over negative is a
Positive.
positive. Now, I've done all 5 of those steps, but I'm still not done.
What?
What am I looking for? It won't be hard to do the next step.
I guess.
What am I looking for? Remember, we have 2 what? Lines. What am I looking for?
Cross.
Oh,
The point they cross. Do I have a point? No, I have one of the variables of the point. I have one of the coordinates of the point. I have the x being 1, but do I know y yet? No. So that's the 6th step here, which is replace or substitute, I should say, substitute or replace the solved variable
It is tiny.
and the original
It would have been a sign.
equation where the other variable is by itself. Okay? So where am I going to put this 1 then? Can I put it in here? You can. But is that going to be easy? Not easy.
No.
I'm going to have to subtract and then divide. Can I put it in here?
Yeah.
Yeah, that's going to be easy. So that's where I want to put it. See how the y is by itself?
Yeah.
I'm going to replace the x in that same equation where the y is already by itself. That's what this is saying. Substitute or replace the solve variable, that's the x, in the original equation where the other variable is by itself. So I'm looking for which equation has the y by itself. It's right here.
Wednesday.
Now I just replace it. What's 3 times 1? 3 plus 4 is 7. So y is 7. Okay? And what is my point then that they cross? 1 what? 1, 7.
1, 7.
Okay? And that's called substitution.
Wait, how did you get 7?
How did I get 7? I took the 1. You with me, Gannon?
No.
I plugged it into the original equation that was solved for y.
Oh,
Because x is 1.
okay.
So I'm substituting right here. What's 3 times 1?
3.
3 plus 4.
7.
That's how I got the 7.
That's not hard.
graph it.
I was confused.
Now, let's say we were graphing it. How would I graph it?
You would find the
The
point.
first one's pretty easy, right? Because you would start up what?
4,
4, and then I would go up what?
3,
Up 3 and over
1.
1.
How many lessons?
And I could keep going like that. It's gonna go, I can go down 3 and over to the left 1.
Yeah, I got 12 too.
Okay, so that's the original one. Here's why it's, because somebody said, well, I don't know why, I think it was Canyon, right? He said, I don't know why you just don't graph it. Well, that's easy to graph, I agree, Canyon. But this one is not. What would I have to do to graph this one?
Find the
Get y by
decimal.
itself.
Get y by itself, so do that. Subtract what?
Subtract 2.
2x to the other side, right?
Uh-huh.
So negative 3y equals negative 2x minus 19. Okay, Seth, go sit over there. You're talking too much.
No, I ain't.
Okay, Danny is then. Danny, go sit over there.
Yeah,
I
Danny
knew
ain't.
one of you guys were talking too much. Now I want to divide by what?
That was probably the first time we talked.
Divide by negative 3.
Take your book.
Don't forget the negative. And this is why it's harder to graph, Canyon.
Take the whole thing.
Because when I do this, what's a negative divided by a negative?
I'll just take the book.
Positive what?
React.
2/3 x, and then I have plus 19/3. What the heck is that? I gotta think about where that is. Where is 19/3?
It's 5 and then barely passed.
4 fifths.
It's 6, because 3 goes into 19 how many times?
6 times.
6 and a third, right? So this is 6 and 1/3. Because doesn't 3 go into 18 6 times? Okay, and then 1 left over. So that's how I got the 6 and a third. So where should I start on this graph?
6 and a
no.
third.
6 and a third. Where in the heck is that?
It's over 6 and barely passed.
6 and barely passed. And then where am I supposed to go?
Up to.
Up to
Over 3.
up 1. So I got to go in that third area.
1,
2 and over 1, 2, 3. Somewhere over in there. And maybe I get my graph right, and maybe I can tell it's at that point, which is at what? What is that point, by the way?
1,
It is
7.
1 and it's up what? 7. But because of those fraction values, I see a lot of kids not be able to do that. So that's why it's harder to graph, is because of the fractions. And so sometimes it's easier actually to do the math and just solve by substitution. So we're going to give you different methods. This is the substitution method. Sometimes the substitution method is even easier than what I just showed you. I did a very difficult substitution problem. Okay? But it can be easier than that if not all these steps have to be carried out, which sometimes it doesn't. Okay? Let's try one more just to make sure you got the hang here.
Oh, I don't look pink.
Okay? So, well, some of you don't have the hang. So we're going to find out. Here we go. Okay, let's say I had 2x plus 3y equals 13 and 5x plus y equals 13. Okay. All right. Again, could I solve them and graph them? Yes. Is the top one going to be easy to graph though?
No.
No, because it's going to have 13 thirds, right? It's going to be another weird little place. So how else can I solve these? I can use substitution. Which equation, this is important to pay attention to, which equation is going to be easier to get one variable by itself? The top one or the bottom one?
Bottom.
How come? There's nothing in front of the what in the bottom.
Y.
There's nothing in front of the y in the bottom. So you always look, when you're looking to decide which one should I get by itself, right? Look and see if there's one that only has a single y with nothing in front, or a single x with nothing in front. If that's the case, we're in great shape, because this is going to be easy to get by itself. How do I get this y by itself? Subtract what? 5x on the other side. That's that easy. So now I have y equals negative 5x plus 13. Okay? Now, am I ready to do my substitution? Yes. So Danny, where should the substitution go? This equation has been solved for y, so where should I put this value for y? Danny, I've solved this equation for y. Where should I put this in for y? In this equation or in this equation?
Not that, top.
Put it in the top one, right? Because we've already solved the bottom one, so we got to put it in the top one. You've got to use both equations. I've had kids who solve one and then put it back in the exact same equation. That's not going to do you any good, okay? You got to put it in the opposite equation. So now I'm just going to replace it. 2x plus 3 times, what am I going to put instead of y? Y leaves the game. What comes in the game?
Negative 5.
Negative 5x plus what?
13.
And then it equals what?
13.
Yeah, don't change that, okay? Now, Rachel, what should I do next? Distribute the 3, yep. So let's distribute that 3.
Negative 15.
So 2x, negative 15x. How come? Positive times a negative is a
Negative.
negative. 3 times 13 is, what's 3 times 3?
9,
39.
9. What's 3 times 1?
3.
3, so it's 39. Equals 13. Now what should I do? Griffin?
Let's,
Yep, I add the like terms. So 2 minus 15. What's 2 minus 15?
Negative.
Think about a number line. I'm at 2, I'm minus 15. Where am I at?
I guess.
Negative what? 13x. I'm going to subtract what? 39. I'm just doing this all in one step here. Because I'm trying to get the x by its what?
so,
Self. Notice I'm doing all this. I'm just doing it faster this time because you've seen it now.
negative 26.
Negative what?
26.
26. Okay. And now I'm going to divide by what?
Negative 13.
Negative 13. And x is what?
2.
2. Am I done?
No.
I see a ton of kids stop right here and just say, oops, I got x. Remember, there's an x and a what?
Y.
And a y. Where do I want to put this value of x? Put it in the solved equation for y. Look where y is by itself. It's always going to be the easiest. Okay, so let's sub it in there. Y equals negative 5 times what?
2.
2. Notice how I put a parenthesis around that, because I'm replacing it. Anytime I do a substitution, I do that. Plus 13. What's negative 5 times 2?
Negative 10.
Negative 10. Plus 13.
Negative.
Positive.
No. 23.
Positive 3.
Negative 10 plus 13.
Jeez.
Positive 3 equals what?
Y.
What?
Stop from that.
So
what's your
what's
point?
my answer? How should my answer look? It should look like a point that they cross. 2 what? 3. Okay? You can stop that now.